Video problem 68, dilution and chemical reactions. This time we're doing a chemical reaction, and so we have our big chemical reaction here. It says a 15 milliliter sample of 0.25 molar potassium permanganate reacts completely with a 23 milliliter sample of iron 2 chloride in the reaction below. What is the molarity of the FeCl2? So again, I always like to write anything that's not moles or grams above the reaction. So I've got 15 milliliters of 0.25 molar potassium permanganate. I'm using 23 milliliters of the iron 2 chloride, and it reacts completely. So in other words, all of this permanganate reacts with all of this chloride. Okay. I want to know what is the molarity of this. So in order to find molarity, what do I need to know? I need to know moles, and I need to know liters. Well, I have the liters right there. Right, 23 milliliters, that's how much of that I have. What I need to know is the moles. So I need to find moles. Right? How am I going to get that? Well, the only other information I have is right here, so I can go from moles to moles. Okay, so let's convert our molarity and our volume to moles. Right? So molarity is equal to moles per liter. Now this is the molarity of the potassium permanganate. So it's going to be 0.25 molar is equal to moles divided by 15 milliliters. And I'll show you a little trick of what I'm doing here. That gives me 3.75. This is going to be millimoles. Okay? So millimoles, just like milliliters, just like milligrams, it's millimoles. How does that work out? Well, let me show you how that works out over here. We have our moles divided by liters, right, which is our molarity, and I'm multiplying that times milliliters. So liters cancels out, but it leaves me with milli. So that's how I get the unit of millimoles for my 3.75 here. So this is my 3.75 millimoles, right? So I'm going to put a milli in front of it. I'm going to go from millimoles to millimoles here. So that's millimoles of K, MnO4. Convert that to FeCl2 and get rid of potassium permanganate. So it's going to be 5 FeCl2s for every one of those. So I'm going to multiply that value times 5, and I'm going to get 18.75, and that's still millimoles of FeCl2. So now I have the millimoles. If I want, I can convert that to moles, but I'm not going to, and here's why. I'm going to take 18.75 millimoles, and I'm going to divide it by my 23 milliliters. So millis cancel out. That's moles per liter, which is molarity. So I get a value of 0.815. Let's go to 2 sig fig, so 0.82. So that's the molarity of FeCl2. Okay? There you go. An example problem of reaction stoichiometry.